Now we are moving on to model 4. Before I go to model 4, I need to give you another formula for quadratic functions. So first formula I've introduced to you is alpha square plus beta square equivalents to alpha plus beta bracket power 2 minus 2 alpha beta. Now I'm going to the second formula. Before I go to the second formula that I need to tell you, so now we need to know the relationship between the sum of the roots and the product of the roots with the quadratic equation of ax squared plus bx plus c. If you're given alpha ax squared plus bx plus c, how this equation is being related to the sum of the root and the product of the root. Now let's say if you are given alpha and beta are the root of the quadratic equations of ax squared plus bx plus c, then you know that ax squared plus bx plus c is equivalent to 0. Now everything you divide by a. So if divide by a divided by a is 1, so b over a plus c over a equivalent to 0. And since you know that, alpha and beta is a root, therefore the quadratic equation can be written as x minus alpha, x minus beta. Now you open up, x times x is x squared. You can open up like that, 1, 2, there's a 3-step, 1, 2, and you open up. Then you'll be getting, the x times x is x squared, x times with alpha times with x is alpha x, and beta times with the x you get beta times with the x you'll get beta x minus beta x, and alpha times beta you'll get alpha beta. So when you expand this, you'll get this. Okay, once you get this, you factorize it, you'll get x squared minus alpha plus beta x plus alpha beta. So now you do comparative. We compare the red color, the b over a is actually equivalent to negative alpha plus beta. Therefore, we can do the conclusion that sum of the root is actually alpha plus beta is actually equals to negative b over a, and product of the root is a blue color. Here c over a is actually equals to alpha beta. So now this is what we call the second formula that I told you. Now you must remember sum of the root is actually the alpha plus beta equivalent to negative b over a, and product of the roots is alpha beta, which is equals to c over a. So now we have done the second formula. Now we're going to model 4. Okay, we're going to model 4. So under the model 4, the first question that we are looking at here is alpha and beta are the root of the following quadratic equations. Evaluate the sum of the root and the product of the root. So since this has a root alpha, and since this is a root as beta, therefore sum of the root is equally equals to alpha plus beta is equals to negative b over a, so negative 4 over 1. So this equals to give you 4. And product of the root is actually equals to alpha beta, which equals to c over a, which is equals to 5 over 1 equivalents to 5. So now we found the sum of the root of this quadratic equation is a 4, and product of the root is actually equals to 5. So now we do second example. So when you go to the second example, you're not given a quadratic equation in the form of ax squared plus bx plus c. So what we need to do, we need to open up. So this equals to 5 minus open. This gives you 4x squared. Open negative 3 square, you get, open negative 3x squared, you'll get plus 9. And 2 times 2x is 4x times negative 3, you'll give you negative 12x. Okay, close bracket, equal to 0. So open up, 5 minus 4x squared minus 9 plus 12x equivalent to 0. So you got negative 4x squared minus plus 12x minus 4 equals to 0. Because negative 9 plus with 4, you get negative 4 equals to 0. So now everything we can divide by 4, or negative 4. So I'm going to divide everything by negative 4. This will give me x squared plus, so not plus, negative 3x plus 1 equals to 0. So therefore, you'll be getting sum of the root equals to negative b over a. This equals to negative 3 over 1. So you get negative, you get 3. And product of the root is actually equals to b c over a, which is equals to 1 over 1. That's equals to 1. So now you got the answer for question number B. Okay, now we continue with model 4, question number 4C. The question is x squared plus k minus 1x plus k squared minus 1 equals to 0. So this equation is already in the model of A, x squared plus bx plus c. Now we need to find the sum of the roots. Now you want to find the sum of the root. The sum of the root is actually negative b over a. Sum of the root equals to negative b over a, which is equivalent to negative k minus 1. That is the b is a k minus 1. So k minus 1 divided by 1. A is 1. Therefore we got negative k, negative times k is negative k plus 1. So that will be the sum of the root. Now let's say we want to find the product of the root. Now you want to find the product of the root. Now you look at it, product of the root. The product of the root is c over a. C over a is actually k squared. What is c? C is k squared minus 1 over 1. Therefore the answer is k squared minus 1. Now we continue with the next example. The next example that we're moving in is actually example D. Okay, if you look at example D, now we got k plus 1x squared equivalent to 12x minus 2k. And this is not in the form of ax squared plus b. So what we need to do is we have to rewrite them in the form of ax squared plus b plus c. So I brought the negative 12x to the other side. So I got negative 12x. Negative 2k, I bring it to the other side. I got plus 2k, which is equal to 0. So therefore, our sum of the root is negative b over a. Negative b over a, which is equal to negative. B is what? Negative 12. So negative 12 over a. A is equal to k plus 1. So divided by k plus 1. Therefore, I got 12 over k plus 1. Now, we're moving on to the next part. Is a sum of the root. Product of the root. Product of the root is actually c over a. C is what? 2k. So, c is actually 2k. Here is a 2k. So, 2k divided by a. A is k plus 1. So divided by k plus 1, you get c over a, actually 2k over k plus 1. So therefore, this will be the answer for section D. Now we are moving on to section E. Okay, we are moving to E. Okay, if you look at E, the questions gives you as 3 minus k x squared equals to 2k x plus 3k minus 1. Now if you look at this equation, this is no longer in ax squared plus bx, so we have to rechange. So I brought the negative 2k to the other side is negative 2kx, and I brought 3 bracket k minus 1, the other side is negative 3k minus 1 equal to 0. Now this is in the form of a is actually 3 minus k, whereas b is negative 2k, and c is negative 3 open bracket k minus 1. So what is the sum of the root? Sum of the root is actually the negative b over a. Negative b over a equals to negative, what is b? Negative 2k. So negative 2k over a is 3 minus k. So you get 2k over 3 minus k, because negative times negative you get 2k. Now we go to product of the root. Product of the root is actually c over a. Every time product of the root is c over a. C over a is negative 3 over 3, and c will be negative 3k minus 1. Therefore, negative 3k minus 1 divided by a is k 3 minus k. Therefore, you get negative 3 times k is negative 3k. Negative 3 times negative 1 is positive 3 divided by 3 minus k. Therefore, this is a product of the root. Now, this is a section C. Now we move on to section D. Okay, if you're moving on to section D, you'll be getting the question as a 2 minus 3p as a of x squared equals to p minus 4x minus 2. So we bring it to the other side. So we got 2 minus 3p x squared minus, because bring to the other side, minus, so p minus 4 x minus 2 come this side is plus 2. Now this is the form in a quadratic form. Now we are going to sum of the root. Now if you look at sum of the root negative b over a, negative, b is what? Negative here, there is a negative here, so negative p minus k, p minus 4, and divided by a is 2 minus 3p. So you get negative and negative is positive, therefore you got p minus 4 over 2 minus 3p. So therefore this is the sum of the product. And move on to the next one, is a product of the root. Product of the root is actually c over a, which is equals to c is what? 2, a is 2 minus 3p, so 2 over 2 minus 3p. So you got the answer. So now we are done model 4.